Okay, so in this video we're going to go over matrices. Yeah, so this is a second part after the first video that was made, and of course the first video we focused our attention on us knowing how to find the transpose of a given matrix, how to add matrices, multiply matrices as well. Yeah, and us knowing the order of a matrix and how important it is to know the order of a matrix, because it leads us, like it gives us a clue of us knowing the order of the answer that you're going to get. And when you know the order of the answer of the matrix that you're going to find, is if you know that order, then everything is going to be simple for you, because that will be the guideline of how you're going to multiply and how you're going to add. More especially when it comes to multiplication of matrices, it's a bit tricky because it requires you to focus on the row by the column, hence if you know the order of the matrix or the two matrices, it's going to help you know the order of the final answer. Hence you doing all the work is going to be simple. But in this case, our main area of interest is what? Us finding the determinant of a given matrix. Determinant. Okay, even us finding the inverse of a given matrix. Okay, so here we are going to focus on a 2 by 2 matrix, as well as a 3 by 3 matrix. Alright, so when it comes to a 2 by 2 matrix, it's a bit straightforward as finding the determinant, and of course we are going to use this example to know the format, or rather the simple formula that helps us understand how we go about finding the determinant of a 2 by 2 matrix. So I'm going to use letters, as unknown variables. So let's say we have I here, we have a C here, we have a B, and we have we have M. Alright, so let's say we use these letters to for us to find the determinant of that matrix. So here what we need to do here is that we need to focus our attention on the diagonals that we have. So we have this, the one that is bounded by yellow, we say that is our major diagonal. Okay, so the one that is bounded by, I would say, red, that is our minor diagonal. So now, for how do we use this for us to get to us knowing the determinant? So determinant we can use we can use det. Determinant of that matrix, we can say it's equals to the major diagonal. Okay, major diagonal, I'll just say major D minus the minor diagonal. So it's a minor D. So meaning what we are going to do here in this case is that we have to multiply what we have in the major diagonal and subtract also the product of the minor diagonal. So the product of the major diagonal, which is I, multiplied by M, minus the product of the minor diagonal, which is B, multiplied by C, and whatever we get here is going to give us the value of the determinant that we are looking for. And that's interesting. So if we understand this part, believe me, any question that you can be given, no matter how tricky it is, if you just know how the determinant comes about, because it's not always when you have to find the determinant. Sometimes you are given the determinant and maybe they're asking to find the value of M, where they have given you the value of B, I, and C. So if you know the setup of how everything goes, then that work is going to be very interesting and simple for you. Alright, so now what about the inverse of let's say I want to find the inverse of that matrix. It's denoted by that. So now when it comes to the inverse of a matrix that is given, is that there are some changes that come in place. Okay, there are some changes that come in place in terms of the arrangement of the members of that given matrix that you have. So first of all, what you need to take into consideration is that before you make any changes on the positions of the values that you have, you need to keep in mind that we are going to divide we are going to say 1 over the determinant. We are going to multiply by everything that is inside. Alright, so what do we change before we multiply? So remember to say here, when it comes to the major diagonal, the major D, which is the I and the M, these two are going to change positions. They are going to switch positions in simple terms. So the position of I will be the position of M. The position of M will be the position of I. So meaning where there is supposed to be I, I'll put M. Where there is supposed to be M, I'll put what? I. But for the two, the B and the C that are in the minor diagonal, these are going to maintain their positions. The only thing that is going to change about them is the signs that they have. So when you look at these B and C are positive. B and C are what? Are positive. Hence they will become what? Negatives. If they were negatives, they will become what? Positives. So if we know this format right here is basically the one that helps us to do what? Find the inverse of that given matrix that we have in either an assignment, an exam, a test, an exercise, so on and so forth. So now when you look at this, it gets more interesting because when what we have here on the denominator is the determinant. So it basically means if our determinant was wrong in the first place, our inverse is going to be wrong. So we need to try our level best to make sure to say our determinant is correct for our inverse to be wrong. So for our inverse to be what? Correct as well. So let's say if us finding the determinant was carrying 2 marks, then us finding the inverse was 3 marks. So it means we are going to lose the what? The 2 marks, and because we have lost the 2 marks as having the wrong determinant, meaning even we are also going to lose the what? The 3 marks, because these 3 marks are dependent on the what? These 2 marks right here, because these 2 marks is the value of the what? The us finding the determinant. So if our determinant is wrong, meaning our inverse will be wrong, so meaning we have lost all the 5 marks, and I believe that is not really something that you'd want to tolerate in this case, because such questions are straightforward questions. It's just a matter of us understanding the concept. So at this point, of course, you can go through as many past papers as you can, exam papers, test papers, but the key thing is for us to understand the format we use, such that no matter how the question is twisted, everything is going to be as simple as straightforward. Yeah. So now, what about a 3 by 3 matrix? Okay. What about a 3 by 3 matrix? What do we get to do? What format do we use for us to find what? The determinant. So let's say we have these members. We have I, we have B, we have X, we have Y here, we have Z. Let's say we have M, we have S, we have what? Let's say you have C, and you have what? L here. Okay, so now our main area of focus is what? Is the first row, and the first row is this one, which has what? ICL, or starting from the other side, LCI. That is our area of interest. So now, how does the first row help us to find the determinant of that particular matrix? So on the I, so the key thing here is that in this 3 by 3 matrix, we have to break it down into 3 2 by 2 matrices for us, because we know how to find the determinant of a 2 by 2 matrix. Hence, we are going to use the same format to for us to find the determinant of a 3 by 3 matrix by breaking it down into a 2 by 2 matrix. But it's not just going to be a 1 2 by 2 matrix. There are going to be about 3 of them. So we are going to have to multiply the I with this part. Alright, so meaning we are saying our I here, okay, we are going to multiply our I with what we have inside. And what do we have inside? We have what? We have M, we have S, we have what? We have Y, we have what? A Z. So now we get to what? We get to C. What is C telling us? Okay, what is C telling us? So of course, on the I, we said we are going to multiply our I with what? With M, with S, with Y, and with what? With Z, like that. So now, what about our C? So our C, we get to multiply our C with what? With this part, as well as what? That part. Okay, we ignore the middle part, which is the M and what? The M and the Y. So we have our C multiplying by what? A B, what? As the X, as well as the S and the what? The Z. So let me get rid of the these colors. We don't want to have too many colors, otherwise it will end up confusing us in the end. Okay, so we get rid of those. Okay, as that. So we get to our L. So our L, we are going to multiply our L with this one here. So meaning our L, we're going to multiply by what? B X M Y. Okay, so now these are the three 2 by 2 matrices that you're going to have, and we know to say here we just multiply the major diagonal, the the major diagonal, the product of the major diagonal minus the product of the minor diagonal. Hence, when you find the determinant of this, find the determinant of that, multiply by what you have here as these numbers, or I'd call them coefficients outside, then add them. Then that will be the value of what? Of the determinant that you are going to have. That will be the overall determinant of the what? The 3 by 3 matrix. Okay, so let's try to get to look at some examples. So we should keep in mind to say it's not always when you are given just a basic matrix. Sometimes they already give you the determinant and they just want one of the variables that is unknown. So let's say we are given 7 here. Okay, we are given 9 here, then here we are given 4p, then here we are given what? 5p. So now we say, the question says find the value of p for which the determinant of a. We have been told the determinant of a is equals to what? Let me do this. The determinant of a is equals to what? -2. So as I said, it's not always when you are just given just numbers inside here, inside the matrix, for you to find the determinant. Sometimes they give you the determinant and they ask you to find the what? The value of one of the unknown within the what? The matrix that you have. So we know to say here, for us to find the determinant, we had to say determinant was equals to what? The major diagonal, which is 7 multiplied by what? 5p, minus what? The minor diagonal, which is what? 9 multiplied by what? 4p. Okay, so since we already have the determinant, which is what? -2, we have -2 here is equals to 7 times what? 7 times the 5 here, what you're going to have is something like 35. Okay, we have a 35p minus 9 times 4 is what? Yes, that would be 36, something like 36. So saying 9 times 4 is 36p. 36p. So we have -2 here is equals to what? 35. So it's more like you're saying 35 minus 36, which is what? -1. So that would be -1p, or we just say -2 is equals to what? -p. Divide both sides by -1, because what we want is the value of p, not -p. So hence our p is equals to what? +2. And you can replace that into the matrix that you have to just to confirm your answer. So remember, so what you're going to have is what? Is 7 here, 9. Okay, so 4 multiplied by the 2. If you say 4 here, 2, then you have 5 here and the 2. Okay, so what you're going to have is what? Something like 7, 9, 8, and what? And 10. So we're just basically saying 7 multiplied by 10. What are we going to have? We are going to have 70. Okay, minus 9 multiplied by what? 9 multiplied by 8. We're going to have something like 70 what? 72. Hence, that's where the -2 as the determinant is coming from. That means our answer is what? Our answer is very much correct. Okay, so now the follow-up question is us finding the what? The inverse of this particular matrix that we have been given. Alright, because we already know we have the determinant, and after we found the value of p, what we now have as our a is what? Is we have 7 here, we have 9, we have 8, and we have what? We have 10. Okay. So now, for us to find the inverse of this matrix, remember to say the for the major diagonal, they have to change the positions. For the minor diagonal, they just have to switch the what? They just have to change the signs. They have to switch positions in the major diagonal and change the signs of the minor diagonal. So meaning our inverse of A is going to be what? 1 over the determinant, which is -2. You're multiplying by everything that is inside. You have 7 here, you have 9 here, you have 8 here, and you have what? You have 10 here. Okay, like that. So multiply 1 over -2, or rather half, by what is inside. So what you're going to have is -1 over 2 multiplied by 7 minus half multiplied by what? 8 minus half multiplied by what? 9 minus half multiplied by what? 10. Like that. So what you're going to have here is that minus half multiplied by 7, it should just be what? Minus 7 over what? Over 2. Here you are saying minus half multiplied by 8, that will give us minus what? Minus 4, because you're saying 2 into 2, 1, 2 into 8, 4, 4 multiplied by negative, that would be -4. For this one, you're going to have minus 9 over what? 9 over 2. Here you're going to have 2 into 2, 1, 2 into 10, 5. You're going to have negative what? -5 here. So it's not always that you're going to have to leave your answer in decimal places. If you have a calculator, you can go ahead and leave it in decimal places. If you don't have, you can just leave it in this manner, and your answer is still what? As good as correct. So that's how we get to find the inverse and the determinant of that matrix. And remember to say, as I said, it's not always when you're given just a basic question, then they ask you to find the determinant. Sometimes you're already given the determinant, and all they want you to do is to what? To find the value of the unknown in that particular matrix. So let's say we have this. Let's say we have A is equals to what? We have 4 here. We have 5, -5. We have 1. We have 2. Okay, then we have B as well, which is what? We have 8. Okay, so we have 8 here. And here we have what? We have Y. And here we have what? A 3, and we have a 5 here. So now, we are taught to say, find the value of Y for which the determinant of A and B are equal. So meaning, the determinant of A and determinant of B are what? Are equal. So for me to find the value of Y, I have to find the determinant of A, because the determinant of A is also the determinant of what? B. So for this, we are saying determinant of A is equals to 4 multiplied by 2 minus what? 1 multiplied by -5. So this is what? 8 minus what? -5. That would be what? 8 plus 5, giving us what? 13. So that's the determinant of what? Determinant of A. We are saying det is equals to what? Positive 13. So now we are going to use the same determinant to do what? Find the value of what? The value of Y there. So for B, we are saying determinant of B, I'll say B in the brackets there, is equals to what? We are saying 8, okay? 8 multiplied by 5 minus what? 3 multiplied by what? Y. Okay, so here we have what? 13 is equals to 8 multiplied by 5 is what? 40 minus, this is 3y. Okay, so we're going to have, this has to go the other side. So meaning you're saying minus 3y is equals to what? 13 minus what? Minus 40. And what you're going to get is, since 13 minus 40 is something like 27. So you're saying minus 3y is equals to what? Minus 27. You divide both sides by -3, -3 right there. We have to cancel out the negative. Okay, so now our 3 into 27, we know to say our 3 into 9 is 3, 3 into 18 is 6, 3 into 27, that will give us a 9. So we're saying Y is equals to what? Positive 9. So that's how we get to find that one. So yeah, that's all from this video, and that's how we get to find the determinant of a 2 by 2 matrix, as well as determinant of a 3 by 3 matrix. And here it's just a matter of us following the concept, and every question is going to be simple for us. Yeah, thank you.